I don't know if I can chat, but I'll take live comments or live question anytime. Are we live now or not?
We are live now. Yeah.
Oh yeah, awesome.
Yeah.
I didn't know that. Okay, that's cool.
I just went live. Yeah.
So how many people are in the room? That's the first time I'm using this software, by the way, so I have no clue what I'm doing.
So like in this room, only me and you are there, and I'll have another person from my team. Rest everyone would be available on YouTube and Twitter.
Awesome.
Yeah. So we have a pretty great number. We are around like 300 RSVPs.
Awesome. Let me just clean up a little bit of my windows, and we're going to do a little bit of repository putting here just so that people can have a little bit of fun. There you go. All right. So
I have just turned off my camera. That's it.
No problem. Is there a way for me to be a little bit bigger than this right now? Because if it's what I'm seeing right now, we're not going to be as big as I think it's going to be. And how do I present? Share screen. There you go.
Yeah, share screen. Yeah. That's what I want to try. Yeah.
All right. So let me just pull that up here. Share screen. And we're going to go with this one, screen 2. All right. So is it possible for my screen to be shared?
Yeah.
There you go.
Yeah.
There you go. All right.
All right. So I'll just give a quick intro about this thing.
Yeah, no problem.
Yeah. All right. I'll just remove from the stream and I'll just share my screen. Okay.
No problem.
All right. Okay. So good evening, everyone. A very warm welcome to our second online meetup under the series of Build with Python on Azure. So this topic would be on Azure Durable Functions, and I'm Shubham, currently working as a program manager at Scalenza. So like we have planned a series of 4 online meetups, which will help you all to scale your knowledge on Python on Azure. So for today's session, we have Max, who's a cloud developer advocate at Microsoft. So before we get started with the speaker session, I'd like to tell you about Scalenza and like today's flow of the event. So basically, we are a platform for professionals and organizations, and we use challenge models to help companies to discover relevant talent and hire better people. So yeah, this is all about us. And now about the flow of the event, Max will be taking up his session. Post that, we'll have Q&A, and then I guess we're good to go. So over to you, Max. All right.
All right. You can just, pull that screen back up. All right. First, hi, everyone. Everyone that says hi in the comments, I'm going to say a little hi. So there's Animash, there's Brijesh, there's Abhishek, and Sai, Kartik, Shandan. So I'm sorry if my accent is all over the place. First, I'm French Canadian, so English is not even my main language. So French is my main language. So how many of you speak French? Yeah, I'm pretty sure there's not a lot of you. All right. So here's a good session here about hold my state, Drupal Functions for serverless workflow. So we're going to go over a little bit of what is happening in terms of what is an Azure function and stuff like this. But this is definitely not an introduction talk. This is a little bit more advanced. So we're going to go into more details and more stuff. We already assume that you already know a little bit more about serverless. All right, so let's keep this thing rolling. I said rolling. So let's move forward with the slides. Come on. There you go. All right, so Azure Functions. So Azure Functions kind of redefine a little bit how we build software. Before, we were just building stuff that were just creating an application, and then you were hosting this on the web, and then you had to like make sure that you had the right amount of servers and you were scaling the right way, and that you were making sure that the data you were processing was saved in your application the right way. So all of this was like really complicated. And you know what? Does anyone need subtitles in just to make it easier? I can turn on subtitles if it's required. I will start it on and we'll see how it goes. So there's a lot of things that are going on here with Azure Functions that changes the way that we build software, because we're not thinking about the software the same way anymore. You have to think about it now as a stream of events that are coming into your applications. So there are many things that can happen here. You can react to timers. You can have an HTTP request, or even like favorite messaging services that are coming in. So before, an HTTP request was just this. It was an HTTP request that were coming in through to your app, and you were trying to do the best as you can with what you have. But now, if you think about an HTTP application, like an HTTP request, this is basically just an event. And an event that triggers when somebody types in the URL in their browser and just type enter. And that when you tap enter, what happens here is the actual request is connecting up to your machine, from your machine to the server, and the server kind of open up a port and retrieve all the data that is coming in. And we have to react to that. Most applications were already handling those kind of events, even though they were not calling them events. Because then that code needs to run on some code. And for Azure Functions, we can have multiple versions of this code that can be ran. So you can have C#, F#, Node, Java, and obviously Python. There's a whole bunch of different stuff that are available here. And it's just that we're switching the way that the events and the things are structured a little bit differently. But then you need an output. Like if you run the code somewhere on the cloud and nothing is ever done, like as that kind of code ever run anyway, we need to make sure that there's something that is outputting out of that functions. So we have a little bit of a mapping here from the events, the code, and the outputs into real terms. So what kind of language do we support? We support all a bunch of those. By the way, Python is not in the experimental languages anymore. This one has turned GA. So I'm sorry, this slide is not up to date. Every time I run it, every time I do the slide, it's always something different. And it's always not up to date. So I just learned to let go. Just like the Disney movie, let it go. Things are going to keep on moving forward very quickly. This team is really fast. So GA, by the way, means generally available. It means that it is supported. You can use it in production. We will support it. We will make sure that it runs, it scales, and every feature that we announce is technically present here. So those languages here are all GA. I think Java is still in preview for a few versions. Python is definitely in GA. There's a few other here in the back that are more experimentals. But if we're just moving the subtitles to somewhere else, let's move it to the top. There's a little link here at the bottom that you might be interested. Basically, just look for Azure Functions supported languages on Google, and we will do that a little bit later today. But basically, this will allow you to list all the different languages that we support. All right. Time to move those subtitles. You know what? Below slide. There you go. So there are a whole bunch of different stuff that we need to talk about. So there's different type of function triggers. It's just like the HTTP request we were talking about earlier. This is a trigger. When somebody press enter, it triggers the code to run on your server. But that comes from the HTTP request. So the HTTP is a trigger. And it's why we have an HTTP trigger. And then you can have different input. So maybe you want to read something off of the blob storage, or from different SQL tables, or a NoSQL database, or anything else. that are in the second column called input. Then there's multiple ways that you can have your output. So you can have HTTP that returns JSON. You can have you can send an email. You can send a Twilio SMS notification. You can send literal phone notification as well. And there's a whole bunch of different things you can have out of this. But that's the basic principle. You have a trigger that can have an input, and then you're going to have the output at the end. And that's mapping exactly to what we were showing earlier. So that was a summary of what is Azure Functions. And there is way more to it, but we want to get to the real good stuff here. And this stuff is called Azure Durable Functions. And for me, this changes the way we think about serverless. Serverless has always been about this stateless version of running the code, because you're only running for a single amount of time for a very specific, like, you want to run the fastest way possible. You want to take the least amount of footprint. You want to make sure that you're not consuming too much resources. So that means you can't start storing values in memory all the time. Like, that was a good optimization way back in the day when you had your servers and everything was running there. You could just like store a whole database into your in memory and keep it there. But in serverless, you can't do that, because if you do that, what happens is your function still runs or your application still runs. So we're still billing you. So you're not using serverless anymore. You're just using an application on the cloud. So you're not really taking advantage of the model. So what we want to do now is I want to show you how you can build those really awesome applications without having to load everything up in memory or to start keeping your application alive all the time. All right, so there's a few concepts for Azure Durable Functions, and we're going to talk about all the patterns that comes with it, and then we're going to get to the applications. So the first thing we're going to want to talk about is, what is an activity functions? What is an orchestrator functions? What is the bindings? And what is event sourcing? So those are important because they define the way that Azure Functions basically execute and run. So you need to have that. All right, so I have this code available in 3 languages. So even though one of them is in preview, I'll show you all 3 of them. So this is basically what an activity function looks like in C#. It will say hello. It will return a string with like string interpolation that will say hello and name, and that's it. That's really all it has to do with Azure Functions. An orchestrator function here in C# will look a little bit more like this, where you need to have a context. So this durable orchestration context will be defined. And then if you want to queue those activities, you want to run this workflow, you have to use call activity async. And we await all of them because we want to wait until we have the result to store it into the output. So we basically storing here, say hello in Seattle, say hello in Amsterdam, and we're waiting for each of them to execute. That's what we're doing here. And the output will be hello Seattle and hello Amsterdam. But let's look at this code in JavaScript. So that's how it's going to be looking like. Just as simple, just the binding is a little bit different. The module definition is a little bit different. In the orchestrator function here, there's a little bit of a difference. So what you're going to have here is we need to use the DF package, which is a separate package that comes with Node, and you're going to be using this orchestrator function context again. This is the same context that we use in C#. It's just now it's in Node, and we're going to do the same call to an activity with the context. So context.df.call activity. This time we're not using await in Node because reasons, and one of the reasons is we don't control the language as much as we control as we want. So in this case, we're going to be using yield, which is just like the same thing that you're using for a for each loop. So when you want to for each, you can plug yourself in this loop kind of pattern, and you can use yield to basically run code before and after, and that's what we're doing here. And now let's show it in Python, because I've heard that's what you guys are like all about. Oh, is the stream frozen? I want to make sure the stream is not frozen. Is the stream
No,
for?
no, Max, it's good.
Okay, cool. So if somebody's frozen, we're good. If it's just one person, we're good. So, all right. So just like Node or C#, you can see here that the activity function is pretty basic. Like the name is in parameters, and you're defining your function. But it's basically every Python function is basically its own app. And that's pretty much how it runs for this one. And you're going to be using string interpolation here again to basically say like hello name. I'm not even sure if this, by the way, is right. I'm just copy pasted from the repo because Python is still in preview. And the orchestrator function will look a little bit like this. So you would yield those contacts, would yield those activities to do the same calls. And we will also need the orchestration context here in Python. So those are all the same code. They're all doing the same thing. We're not doing anything wild here. We're not doing anything crazy. This is all there is to it. Like you're defining a context, you're calling a function, and you're starting the orchestrator here at the bottom, which is a little bit different from the other ones, which are started automatically. Otherwise, that's it. Like that is the orchestrator function and how it looks like. So we're going to run through this process a little bit more in details after. So what is event sourcing? So the way that Azure Functions Azure Function works is that like you get your input, you get your event, and you output the result, and you don't care about anything else. But Durable Function is not that way, because you're going to be orchestrating a bunch of different functions, and you don't want to be calling other functions directly from another functions, right? Because otherwise, what if you do like this infinite loop and you can't detect it because each of your functions don't have it? You don't have the necessary code to detect the infinite loop. So you could basically scale to infinity, like to as many servers as we can, because you're in an infinite loop. And so you don't want to do this. You don't want to call functions to functions. You want to use other ways to do those kind of things. But if the orchestrator function is going to call the same function 25 times, we don't want it to yield 25 times a different result. We want it to call a function once and return the result only once. And so how do you do that? Well, event sourcing is kind of the way to do this, because the orchestrator is going to keep an execution history of all the actions that we're doing. So when you're calling a function, it will know that the function has been called with certain parameters. And what that function is being called with certain parameters is going to wait for the result. And what that result is coming in, it will not execute it again until it has all the proper answers to all those functions. So the orchestrator basically schedules all the async work, and it will shut down. So all the things that are before a yield, that are right after the yield, as soon as it hits the yield and the function does not have a result or has not been executed yet, this will just queue it up and just wait for it to be run. And once this function is finished running, the orchestrator will restart and rebuild the local state from the ground up. So that allows us not to have to run the same function twice or 3 times or 4 times, or even allow us to not call those functions directly. Even though you're seeing those call activity async, we're not calling the function directly. There's a lot of things that are under the hood that we're going to be talking about in a few minutes. So what does it bring us? It brings us improved performance and scalability, eventual consistency. That's an architectural pattern. If there's something you want to Google now, is eventual consistency. Look for this term. It's amazing. It's not just for durable functions. It's for a whole bunch of different patterns for code execution on the cloud and data. So you want to Google that up. This is a good term to look. And we also get a full audit trails and history of everything that has run into our function. So if ever there was something to go wrong, we know what went wrong, which parameters, what are the input and the output of every function in our calls. All right, so let's visualize that, because I speak English and a very bad English, and I want to make sure that you're not just remembering words. I want you to remember the pictures and see like this workflow going in your head. So let's take our example that we had earlier and just squish it down. We're not going to do 2 cities, just 1 city. we're not going to include like all those different functions. We're just going to focus on the orchestrator itself, right? And we're going to simulate the way that the orchestration is going to work. So when you start the orchestrator, what's going to happen? So first, let's start the orchestrator. So the orchestrator is going to start, and the execution of the orchestrator is going to start. So first thing first, it's going to initialize this outputs variable with all list of string. And by the way, the examples are in C#, but it might as well be in Python. It does not matter because the same things will happen here. Note, it does not include imports, Naresh. The thing is, we're not doing imports. We're not doing like those kind of like, we're keeping the code to as simple as possible to make sure that I'm not showing you like a whole screen full of code. I'm just showing you the relevant code. All right, so the orchestrator function has started and executed, and then it reaches this second line. And the output's going to be, we're going to add something, and then there's the await. Just think of it as the yield in Python here. And the context here is going to say, let's call this activity asynchronously. And the function that we're going to call is called sayHello. And the parameter here is going to call Amsterdam. It could be anything. It could be an object. Everything is going to be serialized anyway in JSON. So it does not have to be simple types. It can be really complex type, very big types. It can be a megabyte of data in there. It does not matter. So outputs that add. So as soon as it hits this line, what's going to happen is the orchestrator is going to be talking to its execution history and say, well, did we run that before? And the execution history is going to say, nah, nope, we did not run that before. So what's going to happen here is we're going to schedule a task to run the sayHello function with the parameters Amsterdam. And then orchestrator will complete. It will shut down itself because it knows that it will have to wait until this function is finished invoking before it can resume. It has to await the result. Right? And at some point during the execution, so we don't know when, quite quickly, but we don't know exactly when, the activity function is going to start. And this function is going to complete with the same hello Amsterdam that we saw earlier. It's the same code that we just saw earlier in the stream. And as soon as this return hello Amsterdam, this is going to be the result, the output of this activity function. And then the function is going to shut down, right? But then the orchestrator will need to restart at some point. So as soon as the orchestrator restart and define, it will go through the same process again. So it will restart the outputs. It will run on the second line. It's going to go through the await, call context activity async. It's like, did we run that before? And the execution history this time is going to say yes. And here's the result of this function. So it will have the hello Amsterdam in its result. So at that point, it will continue the execution, return the output. So the execution is going to be completed. It will return hello Amsterdam. Now the orchestrator is going to shut down, and the orchestrator will be completed. It will not restart again for this time. So have you seen how this whole process has been happening? This whole thing has been basically separating all those things together that you can start other functions and call activity async on the sayHello with Amsterdam is not going to be called twice. It's only going to be called once. Due to the execution history, this execution history that you see on the screen is our event sourcing that we talked about earlier. That's exactly what it is. So that leads us to amazing patterns now that we can use. Because before, if you were just thinking of Azure Functions vanilla, the only thing you had was let's run a code. Well, let's define an input, a trigger, and then run some code and just generate an output, right? But the thing is, it's more than that. Now we can do those crazy patterns. What if we wait, since we are waiting all of those, what if we take the parameters, the result of the first function, and pass it to the second one, and the second to the third, and the third to the fourth? This is called function chaining. And you can call all those functions in sequence. So now you can have this workflow of things that you want to run, this bunch of code that you want to run in sequence, but without hosting a whole HTTP server on a VM or on app service or anywhere else. You're loading up your application. This is all in serverless, and you can run this code in sequence. And then that's one of my favorite patterns. It's called fan out, fan in. It's like, let me show you the code that runs with that. It's still in C#, by the way, so it's the same kind of code that you will write in Python. It's just that things are a little bit different, and the function definition, and there's less curly braces and stuff like that. But the idea is the same, because we're not running, we're just running orchestration code here. So we're going to start with a list, and in .NET, we define tasks as our parallel processes that are run side by side. So we're going to run all those tasks here in parallel, and we're going to get this call activity async. It's going to call a function, and we can see here that there's a wait call activity async for F1, right? So we're going to get a whole list of items that we want to process. Here we have object, but think of it like of items you want to process. Maybe it's invoices or stuff like that. I don't know. And then we're going to go through all those items, but then we're going to call activity async on F2 with our work batch item. But you see something here that is missing right before the CTX, right? There's no await. So that means we're not going to be waiting here. What is going to happen in this case is we're going to add this task to our list. But what if there's 100 work batch items? It's going to queue them, all of them. 100. What about 100,000? Will work as well. 1 million? Yeah, it's also going to work. So you can literally have just a function that returns a list of things to do, and another function that will process those items and just queue them up. And then the line that is highlighted here, await task when all, is where the magic will actually happen. Because the orchestrator function will wait until all of those tasks as completed before it returns, or at least before it can move forward. So if we have 100,000 items, the orchestrator functions might resume again a few times just to look up on the results, but only when all of those 100,000 items have finished execution will we be able to move on to the next. So when all of those functions have finished running, we're going to get into this aggregate all end outputs, like this parallel task as sum. So you can run something to summarize all those functions, but then at the end, you're going to call activity async F3. And this time we're going to wait again, because you might want to save it. You might want to do something with that sum. So I have a sample with that later that I will show you. Like, it's a very good example of fan out, fan in. But that's a good example. And I also have an example, by the way, on Python about that one. Then we have human interaction with timeout. So let's say that you want to request an approval and you want to wait for somebody to give their approval for, like, I don't know, a document or a process that needs like somebody to approve something. Like, oh, I want to make this changes, but I need like my boss's approval. But my boss is currently, is writing. He's in his car. He's on a work meeting, so he cannot approve yet. But what if he's in vacation and you want to cancel that, right? So you need to have the process approval process, and you need to have the escalate one because, well, that person is not available. So you need to do something else in case that person is not there. Well, that code would look like this. And again, it's just a bunch of orchestration context with call activity async. There's nothing weird here. It's just the same code always. So we are waiting this call activity async for this request approval function. But then what's going to happen is we're going to define a timeout. And we're going to say, you know what, this timeout is going to expire in 72 hours. And we're going to create a timer. And we're going to start waiting for either this external event, which is an approval event, or for this timer to end. So whatever of both happens at first, we'll handle it differently. And that's it. Like, this is a simple task that you're playing Lego. If anybody ever played Lego like in their youth, this is basically what you're doing. Is you're putting the blocks together and you're building an application by basically defining the process. It can be as simple as creating a timer and basically say, if nobody answered that within 72 hours, well, I want to escalate it. I want to run a different process. But here's the thing. Like, this sub-process does not need to be an activity. It can be another orchestrator. If you're looking at in the for each here, you can see like call sub-orchestrator async. It is a total possibility for you to run this code and start another orchestrator to handle the whole process. And this one is in a different block. So if you're talking about those Lego blocks, it's just like taking two constructions that you've made together and just smushing them in. It's as simple as that. All right, so I've showed you the possibilities, but now there are things to know. And I see I love raccoons. I have not seen all the raccoons, by the way. Like, this is just like the second one. There's more raccoons coming. So there's many things to know. First, on the language support. Generally available, which means we will support you. Everything is going to work fine, is C#, JavaScript, and Node. All those things that I talked about are all implemented in those two languages. Python is in preview as of March 30th of this year, so it's not generally available yet. I've tried to create a demo that will be working greatly, but it's not quite there yet for me to run it on my machine confidently. There are things that are not working in this Python version. As an example, the sub-orchestrators are not working. The create timers are not working yet, not for Python. If there's other language of interest, please let me know. But I think so far, C#, JavaScript, and Python are, I think, the main three languages that we need to support. So there are important details and limitations. So the orchestrator code is replayed on every reiteration to restore the local states, right? I'm reading the slides. So the functions called themselves are not replayed. So that means that every time the orchestrator will rerun, will restart, you will be charged like this execution, like in the cloud on Azure. Well, you have 1 million free execution, so that still runs, so there's no problem. But it also means that the code must be deterministic. And that means it has to return the same thing every time. So don't write logic which depends on random numbers. So if in an orchestrator, if you're generating a random number, it might return a different number every time. And that is bad, because you want this function to be deterministic, to be always returning the same result. So if you need to generate a random numbers as part of your decision process, put it into an activity functions. If you need to use datetime.now, we have our own extensions on top of that to generate a datetime.now that will be Drupal Functions compatible. So never do I/O directly in the orchestrator function either. So if you're reading stuff from a disk, you might not be on the same machine. So you might get a different result. I'm not saying it's not possible. I'm just saying that don't do it, because you will end up in a weird state and in a weird bug, and you will not like it. Do not write infinite loop. You might want to have something that runs infinitely, but every time you start a durable function, it will keep on adding onto this execution history. And if your function never finishes, or if the orchestrator never really ends and complete, what will happen is you're going to have an execution history that will be forever long. It will never end. And at some point, you will end up into bigger issues. So if you have a process that needs to run longer, we have a different process that will basically say context continuous new, which is allow you to bypass this infinite loop thing by restarting the same orchestrator with the same function but with a different execution history so that you're not burdened by the previous execution history. So here's a different thing. Durable Functions. It is not a product on Azure. It is just an extension on the existing Azure Functions. And it runs in user space. So we're not running your code in like different stuff. The only thing we're running differently might be the Python worker, which is hosted on Azure, but everything that you see in your code is all basically just in user space. So when you're all right, and what is behind this durable functions is basically just Azure storage. So all this queuing, this execution history, the way that we pass messages in between the things, like the queues is all your activity execution. Table is basically your event sourcing with input, output, result in history. And the blob storage is used for anything that does not fit in the tables in the column. So all of this, we've done an abstraction for you all that you will not have to write all this code. So if I wanted to write a function that calls another functions, I might want to have function A queue a message and function B unpile that message. But what if this message cannot be unpiled because like it's you need a poison queue, right? So things that are not being delivered. So what happened? How do you handle that? You don't have to write that code. We wrote it. What if you're trying to queue a message, but the message content is too big? You don't have to handle that. We'd already done that for you. So all those different problems, we've solved them for you. They're all in the durable functions. And always remember that exception and the errors are a valid output of a function. So if you return, like in C# a stack trace with everything like where it went wrong, it's still a good and valid result. Let me see the question here. Can we work this on online Kubernetes lab? Azure Function can run on Kubernetes by using something called Keda. I can write it up. I can pop up the browser a little bit later about this. And since durable functions just run in user space, yeah, everywhere where a function runs, durable function can run. And in this case, Kubernetes, it works. The dashboard could be accessed by orchestrator code. I do not understand the question on this one. I will pass and we'll see how it moves. All right. So every good story ends up being like, especially for me, how did I break it? And I broke Azure Function a lot of times. And Azure Durable Functions, I broke it a few times. And one of the things that I loved is that the team, instead of being unhappy about me breaking their stuff, they said, thank you so much, because you broke it so that our customers don't have to break it. And I really love that team. Azure Function is a great team. They deliver a lot of cool features for us. So let's show you the code in which I blew it. In this case, I was using a link resolving application. So my goal was to basically say, let's do an HTTP call on that function and see if it's still alive. Is it return a 200, as in the code is, like the page is still there? Does it return a 400, as in the page does not exist anymore, like 404, right? So here's what happened. So this is the same fan out fan pattern that we saw earlier. So the call activity function here would return the list of all the links that I wanted to do. And then I would start that list and I would do a for each, and I would call this activity async as part of it. And that's it. And I did a task that went all. And it ran very well for small samples. But at some point, there's a few of those that are like, certificate has expired. So those would return an exception. And there's more than you think about that. But then there's a few 404, and I was using ensure success as the HTTP code. So if you're not returning a 200, I would throw an exception. So here's what happened. I had about 100,000, 200,000 links. And out of those, maybe 10% were errors or exceptions. And out of those exceptions, there's a whole bunch of them that are, I would say, a few kilobytes of data in terms of string output. And every time the orchestrator would start those, it would have to rehydrate all of those exceptions. And all of those results will be exceptions all the way through. And so what would happen here is I basically crushed the Azure storage in the back. So you have to make sure that you're handling exceptions properly in your Azure Functions, especially in Durable. Because if you're queuing up a huge amount of data like I'm doing, what's going to happen to you is you will end up taking a function that should run in about 5 or 10 minutes and make it run for 3 hours with 160 servers like I did. So error handling, still very good, still very important. What about downtime? How to remove this? You're probably thinking about the cold start. You can run Azure Functions on Azure Premium Functions, but then it's kind of a mix between consumption and the app service model, right? So you want to be always on, but you're not. But you want to use consumption model as well, right? So consumption, you can scale down to 0, which means that every time your application starts, it has to take the code, put it on a server. From that server, it has to start a runtime. And then from that runtime, it has to start your application and then run the code. And you have to do that for every new service. With premium functions, we basically guarantee that there's one that is always up for you. But the problem here is that you're reserving compute. You're reserving resources for us to run this code. So you have to pay for that machine that you're reserving. So there's no real foolproof way to get your application to run, like to be hot all the time, to always be in memory and always be ready to run. So here's how it looked like on my end when I was running this code. I was 146 servers. There was a few requests, maybe 4 per second at some point. But if you're looking at a dependency called failure rate, that is basically Azure storage. I was through the roof, like 100 errors per second, 50 errors per second, sometimes almost to 200. It was a disaster. So please do your error captioning properly. Here's another raccoon. And I have 2 samples. So those are good things to take a screenshot of or just type it into your browser. I'm going to give you a few seconds. And I will take you to this code right now. So the first thing I want to mention is Azure Functions. So you're all seeing this. So let me just zoom in a little bit more. So Azure Functions is on GitHub/Azure Functions, and everything, and I mean everything, is open source out of this. Their documentation is here, the runtime, the core tools, the developer tool for Visual Studio and VS Code, the UI for the portal in Azure is also open source. All of our templates are open source, the CLI, like everything. And we have repositories for all the things. So for example, if when you look at the Python worker, we have it here. That is the Python worker for Azure Function in general. So function 2, function 3, which version we support out of those, out of file issues, etc. The things that are interesting for us is Durable Functions. So let's click on this one for example. Like I said, it is an extension. There's a different version of NuGet, and we can see here where things are going. And I did not even know that PowerShell was in planning. So my slider yet again out of date. So C# is generally available. Python. So here we can, what if I click on it? I've never tried it out. So Durable Function for Python has been started since that date. And we have more stuff. We'll go at the bottom here. We have the link for Durable Python. All right. So all of this stuff here, we can look into it a little bit more and see like how does it work. So the orchestrator example that we were talking about earlier is here. You want to do find out, find in. There's a sample here with TensorFlow. So if you want to run something through TensorFlow and classify images and show me the result, like this is how you would do it. There's a whole sample in how to build it. Let me show you a real example that is built in Python. Let's classify some images. Let's do 100, dog or cat. So this thing is going to start creating more and more, it's queuing up all those pictures, and it will try to classify all of them. But at some point, it will automatically start to scale up. So all those functions are going to be running from 1 server to 2 server to 3, 4, 5, 6 servers. And all of that without you knowing about it. Just because we're using that model. And all those cats and all those dogs are just being classified. And we've done about 5 or 6 images per second, which is not the best, but it's kind of very good for an Azure function that runs some TensorFlow code. If you want to see that code, by the way, it is available on Anthony Chu's repository here. So the HTTP code is in the www, and the Python code is in app. This is, by the way, still very preview. So I'm going to show you the Python code for that so we can start looking at it. So they run all those stuff into a Docker file, but let's look at the different values that are available here. So the first thing we have is host.json. That basically allows you to say, here's the extension we're going to be using, the different bundles and blah, blah, blah. So this is not as super interesting. Proxies should be empty because we're not using it. Requirements are going to be the things that are necessary to run this function. So all of your requests, your Azure Functions dependencies. So just like we talked about earlier, all functions start with a trigger, right? So how do you start a durable function? How do you start an orchestrator? Well, you need a classic function to start it. It can be an HTTP function, but it can be also any of those other triggers we saw. So what if you have what if you react just to the fact that an image was uploaded to storage and you want to run an orchestrator out of that? It's totally possible. It's definitely possible. So let's look at this HTTP start here. So for those wondering about the imports, here's a few imports. There's a few of them here. So we're going to define an async definition for the main in here, and we're going to do an HTTP request, and we're going to have a starter. In this case, it's kind of using user IDs and stuff like that. But basically, what we're going to do here is we're going to start a Drupal orchestration client from our DF that is defined here, and we're going to define our inputs. So the image count we had earlier would be here. And the client is going to use this function called start new, where start new is defined here. It defines this orchestration function here, this orchestrator as pet classification orchestrator. So I'm going to copy that to my clipboard, and it's going to pass in the orchestration input. And it's going to do a create check status response. And for this, it basically allows you to monitor the orchestration from an HTTP endpoint, any endpoint, really. So let's look at this function, because once we started it, this orchestrator is started on its own. So let's take a look at what it looks like. So let's go back to our app and look at the pet classification orchestrator. You may notice here there's a function.json. Like this is technically the bindings that we're talking about. It binds the orchestration trigger to a context and the direction of the parameters. So we're going to see those, for example, here. So this context is a durable orchestration context. Can you tell skeleton architecture as diagram orchestra code with real-time use cases? I don't have a skeleton architecture because like it's very independent to each and every one of them. Like how you want to build your application is very workflow dependent. Real-time use cases are going to be interesting because we're running off of eventual consistency. So if you want to run real-time scenarios in any kind of serverless application, you will encounter issues. So you will not be able to return a real-time result all the time. It will always be delayed, so it's never going to be like sub 10 milliseconds. It's always going to be like more than 100 milliseconds results. All right, so our orchestrator function, same thing that we saw earlier. We're going to get our inputs. We're going to get our call activity to classify our images. So all those images to classify, we're going to have all those IDs. And then we're going to call this activity to classify those images. And just like before, like we're not yielding. This is the fan out, fan in pattern again, but this time it is defined in Python. So we're going to classify all those images and going to yield back when all of those have been completed and only when they have been completed. And when it's done, we're going to return a summary of everything that's been done before. All right. So take a look at those get images to classify and classify images. So this one is super easy because it will just return a whole bunch of different pictures. So it will generate up to 1,000 pictures, which makes me want to push it a little bit to this limit. Let's put 1,000 and see the program manager in the back start screaming at me. And then we want to see the classify image. So the classify image we see here, there's a whole bunch of different stuff, but this time we see there's a model and there's our labels. That's because it is actually a TensorFlow application here. Like there's a TensorFlow model that we're running and we're running the code. Like this is not smoke and mirrors. This is the actual code. So the function you're going to have here, like we're going to import our model, but all the rest, we're going to try to get to classify this image. Like this thing is still running, but this is probably scaling up now. So all of those are going to be our models that's going to be running this predict image from URL and returning whether it is a cat or a dog, and all this in async mode, running Python, running TensorFlow on the cloud. This is where we're going with Durable Functions. If you want to see more samples, the one I showed you earlier, there's Drupal Function API scraping that I did in .NET. So it's the same kind of things. I did in Node as well. So same thing. There's the crawler, the HTTP start, there's your orchestrator, there's a few different functions. And there was probably more that we could show you on this. So one of those that I'd like to show is the one on reddit.com. And I go into the subreddit called .NET. And let's take any of those. Let's say this one. I have no clue if it's going to be a good one or not. But basically, when you're here, I'm using the same process where I created this this little function here, this extension in Chrome, where when you click on it, it's going to start a Durable function in the back, and it's going to keep you posted on what are the emotions that are felt in the comments. Like, is this thread here just positive? Is it negative? Is it neutral? Like, what is it? And as soon as we get the result, it would show here. Apparently, the schema might have changed. So things have not worked as well that I taught. So let me see one that I know that is running well. Let's see this one. It's going to start. This one is positive. So you kind of know a little bit like what is going on in the back. And for this code, let me just give you another link. The Reddit emotion analyzer for this. All the code is available. I show you how to deploy it. You can clone it, run it with the IDE that you want, and how to start it. And so when you use durable functions, there's a ton of new scenarios that becomes available for you. So I would love to get all of your questions now if you want. So I thank you so much for all the time you spent here. And otherwise, you can reach out to me on Twitter. You can email me if you need to. If you want my profile, it's on ak.ms/maxcda. But otherwise, I'm open to all questions. Let's see. We have to set environment also while classifying. I am not sure 100% what are the environment that you need for this one. Let me just go back here for the image classifier. So the Python sampler, this demo, this whole Python one is really special because it runs. Let me just get this repo up and running. You can close the other ones. Is it still running? Yeah, it is. So this one here runs out of a Docker container, so it is a little bit different. They are still pretty much highly in development mode for this one. They're not ready for production quite yet. If you can make it run, it works. But there's like create limitation, like the create timer I talked to you about earlier that is not available. The sub-orchestration are not available. Drupal function comes with Drupal entities, and this is not supported yet. It's planned, but it's not supported. Like the tooling is not quite there yet, so you're not going to be able to run this with the existing tooling. So there's a whole bunch of different stuff that are still pending. But if you really want to dig into this, like, and start understanding a little bit of how it works, it's definitely something to look into. My pleasure. Was it Karthik? I think.
Yeah, it's Karthik.
Karthik. Yeah, me trying to copy the Indian accent is just terrible. I'm like, it's mixing up the English, the French, and maybe a little bit of Spanish sometimes. So like, yeah. So can you tell more regarding function chaining? What do you want to know? Because there's no limits to the amount of chaining you can do. Like, you can literally loop and chain at the same time, right? If you have a for each, you can put the item here and just chain off of that. So you could chain technically 150 from one function to a million functions. Just be careful along your chaining because the execution history is real. And at some point, the orchestrator will need to integrate the activity, the execution history, and this will come to bite you if you're running functions that have too many functions to run.
So I guess, do we have more questions?
Yeah, let me just open up those repos for those samples because they're always fun. Those I can close for now. So function chaining for Python, if you're looking into it, there's always the orchestration you can look into. And that's basically it, right? You call a function, you chain one, result one is passed in here, and so on. That's how it does. So can you tell regarding the patterns? I'm not quite sure I understand the question, but let me do it again. So basically, the same thing that if you want to call another function, you don't do an HTTP request on another function. What you want to do is basically queue a message and then have the other function pick up that message and run out of that, so that you're not calling a function directly. So if the URL changes or things like that changes, that becomes a problem. So the chaining method here, what it does is just, it does exactly this without you seeing it. It is what this pattern basically allows you to do. All those code, what I call plumbing code, like when you get into a house, you expect the plumbing to work. You expect the electricity and the outlets to work. You don't want to do those kind of things, because like if you had to wire cables every time you want to plug in your TV, that would be like very bad, or you could get electrocuted at some point. So what we're doing is we're doing this thing that you're going to have to do all the time, because there's always people wanting to call other function or do other stuff. We're doing it for you. That's what we're doing basically. Is millennials also come under the Drupal function chaining? Millennials. I have a trouble understanding that one. I think that one is lost in translation. I'm sorry.
All right then.
So for all of your needs, let me just keep two tabs up. So we have this function here, and let me go and Azure Functions. Yeah, sure. Those are the main two that you might want to have. So this one is the Drupal Python ones, and the other one is the Azure Functions. Like this is kind of the hub for me for everything around Azure Functions. So you can open up issues here, you can create pull requests and stuff like that. But basically, the documentation is linked from here. All the different code, all the different repositories where you can file an issue are here. Or if you're just looking into the repositories itself, like the Python Drupal function is not here, I will probably going to do a pull request for this one. Like that might be a good one. But otherwise, that's it.
All right. I guess we are done, Max.
Awesome.
Okay. So thanks a lot for joining and for all those amazing insights. So I'm very sure our viewers out there would have find it informative as well. So all right. I mean, what you could do is, Max, maybe you could share the links in private chat and I could drop in here and they can just take it from there. If you have some links to share.
I will just drop the two main functions that I was talking just a few seconds ago.
Great.
So that you can just reshare them.
Yeah.
And you know what? Let me just do a pull request on this page right now, because this needs to be there. So readme.md. Let's just make sure there is no pull request existing for that. And edit.
So also to our viewers, we'll be having a quiz on Azure Durable Functions, like on what are the topics which Max covered right now. So you can take up the quiz. We'll go live on Sunday, and whoever scores above 60% will get a certificate from Skilenza. Also, guys, show some love. Do tweet about your experience, like what did you like and how was the webinar. You can tag Max. I have dropped in his Twitter handle. Also, you can tag us too. And the hashtag, like give it a hashtag with the hashtag Azure Pi Day. All right. Okay, Max.
Awesome.
So, it was a pleasure having you. Okay.
See you soon. Ciao.
Okay. Yeah. Bye.